Here we go. Finally, I get to do some physics without pictures, some calculations. Lesson 1, acceleration. Acceleration is the rate of change of velocity it's the rate of velocity change per second. Now, what the heck does that mean? Acceleration is how fast your speed is changing, although really it's how fast your velocity is changing, because you can change your velocity in two ways. Since velocity is a vector, it has both magnitude and direction. You can either change the speed, or you can keep going at a constant speed but start turning corners. You're also accelerating. We're not going to look at that second one very much. So in this unit, in this section, in fact, in all of Physics 12, we're going to be looking at constant acceleration, not changing acceleration, which means that the velocity change per second is constant, because that's acceleration. The units for what are the units for acceleration? Again, I'm going to strongly encourage you to memorize what units go with which things. It really cuts down on your thinking. You'll do that naturally, Courtney, as you do the homework. But if, as the test rolls around, when I say, hey, what are the units for distance, or what are the units for acceleration, you're not sure, you might want to write them out a few times. Hey, what are the units for acceleration from last unit? These are the most common acceleration units. These are my preferred acceleration units. I will introduce one other one to you because of cars, but we'll get to that. Acceleration is a vector. It matters whether you're speeding up or slowing down. It matters whether the direction of the acceleration is in the same direction as the velocity or not. But it's really difficult to visualize. In fact, the Science 10 component of physics, I know that over the years I have had many conversations with science teachers across the district helping them visualize acceleration direction, because most of them don't have a strong physics background. Partly because we tend to confuse it with velocity. Acceleration is not the same as velocity. The direction that an object is moving and the rate at which it is moving are both related to the velocity, not to the acceleration. But to determine the direction of the acceleration, here's the key idea: we need to see how its velocity is changing. This is as direction-y and vector-y as I'm going to get with you. We're going to try and spot patterns, and then we're going to abandon this method because it sucks. Here's what I have. We have an acceleration. Do me a favor, put a little vector sign above the acceleration. I forgot to write it in. And the acceleration is 1.25 meters per second squared east. You know, anytime they give me a compass direction, I almost always, somewhere off in the margin, like to write a compass rose, because I can't tell you how many times I've screwed that up. So I'll do that real quick. If your initial velocity is 0, this is part A. Part B, we'll do it differently. How fast are you going at 0 seconds? 0 meters per second. We can fill that in. If you're accelerating east at 1.25 meters per second every second, which is really what meters per second squared means, and you started off at 0, how fast are you going after 1 second? Direction. Okay. How fast are you going after 2 seconds? Direction? East. How fast are you going after 3 seconds? Let's make it a little more interesting. Part B, instead of starting out at rest, let's start at 2 meters per second, east. So at time 0, we're going 2 meters per second east, and we're also accelerating every second at 1.25 meters per second east. How fast will I be going after 1 second? We're starting out at 2. We're going east 2 meters per second, and our speed is changing at 1.25 meters per second east every second. How fast will we be going after 1 second? Oh, I thought you had a solution. Yeah, say it loud and proud. Direction? We keep accelerating. After 2 seconds, how fast will I be going? do you guys think? What's the pattern? What are we doing here? 4.5? How'd you get that? When you're accelerating at 1.25 meters per second east and you're traveling east, what we're really saying is every second you gain 1.25 meters per second. So you're saying, 1.25 meters per second. What do you say? 4 point? I agree. What about after 3 seconds? It's going to be 5 point, what do you think, folks? 7.5? What's the pattern? If I want to, now we can do this by writing out charts, Ryan. I think, and this is a leap, I'm going to give it to you and see if you agree with me. I think the speed that we're finding, which I'll call V final, I think it's the initial speed plus the acceleration times the time. See if that works. Let's try it for 3 seconds here. What's your initial speed in part A? What's your initial speed in part A? What did they say that our initial velocity was in part A? 0. So in theory, I could go 0 plus, what was the acceleration? 1.25 times, how many seconds had elapsed? 3? 3 for this one? If I do that, I should get 3.75, do I? Hey, let's try it for this one. Now for this one, what was my initial speed? 2 plus 1.25 times 3. Does that give me did that work? Oh. You know what's nice about this equation? I think it'll also work for decimal times, which are hard for me. Like what if I said, how fast are you going after 6.8 seconds? I think I could just put a 6.8 there, Courtney, and let my calculator do it, instead of trying to somehow figure it out up here. I wonder if it'll also work for, something like this. So now we have 2 meters per second west. How could I write 2 meters per second west? What would be a shorter way to write that? Negative. Ooh, I like that. I like that. So my initial velocity, I'm going to say, is negative 2 meters per second east. No, Mr. Dewick, it says west. Isn't negative east west? Okay. What's our acceleration? Positive 1.25. All right, smarty Alex. So after 1 second, how fast are we going? Andy. Oh, I thought you had it there. Sorry, I looked at the wrong person, Andy. Jin. Did you have it? Negative, I agree. Now let's see. He said 3.25. Are we accelerating in a negative direction or in a positive direction? We've defined east as positive. So what do you think? Oh. Or you could say 0.75 meters per second west. We're going, which way is west for you guys? That's to the right? Okay, so we're going that way, but we're accelerating this way. We're slowing down. After 2 seconds, how fast will we be going? 0.5 meters per second east. Sorry, say it again, nice and loud.
0.5 meters per second east.
Somewhere in between 1 and 2 seconds, we change direction. Now, we can keep using this chart pattern, or if you were clever, by the way, you could have gone like this. My initial velocity is negative 2, plus my acceleration is positive 1.5 times 2 seconds, and, oh, ha! Whoa! Huh. Oh, it's 1.25, Mr. Dewick. I missed the 2. Sorry, that's important, typing things incorrect. There. So my gut, Lindsay, is after 3 seconds, I'll be going 0.5 plus 1.75, or negative 2 plus 1.25 times 3. Which way is faster? I don't know. Which way is easier? I think using the equation. So I wrote down, oh, come on, pen. I wrote down here, there has to be a better way to do this. Please let there be an equation. There is. Way shorter. So whenever the velocity of an object changes, the object experiences acceleration. In fact, you'll see acceleration defined as a change in velocity over a change in time. Do we have a symbol for change in? Okay, so you'll often see it written like this. Except, Courtney, time is always a change in, so you're going to see often we won't bother putting the delta there. It's just laziness, Haley. I can't say why. It just happens. What's our symbol for acceleration? A, and it's a vector. Now, you're going to notice a lot of the time we're going to be a bit sloppy with the vector sign because sometimes I'll just say find the magnitude of the acceleration, but okay. Oh, vector. Units, we already said this, but you're teenagers, it bears repeating. Meters per second squared. Velocity has the same symbol as speed. Speed has a symbol v. Velocity would be v bar, but I did say speed, so speed. If the velocity at the start of the time interval is vi, what does the I stand for? Initial. And at the end of the time interval is vf. What does the f stand for? Final. We're going to use that all year long. Okay. Then the change in velocity will be vf minus vi, because change in anything is final minus initial. Oh, and if the time at the beginning of the time interval is ti and the time at the end of the time interval is tf, then the change in time is tf minus vi. So I can take this and I can break it up into a equals vf minus vi all over tf minus ti, or you'll often see it written this way. Because we get lazy with time. Time is always a changing. We're actually not going to this is the equation we're not going to use as much. We're going to write it in a nicer form. Same equation, but we're going to rearrange it. And that's the one that you'll probably memorize out of sheer laziness, which, again, Sheldon, is the only reason you should have to memorize stuff, because it saves you time, because it makes things more efficient, because you're lazy. Oh, little note, change in anything is always final minus initial. So, since velocity has two aspects to it, it's a vector. It has both speed and direction, magnitude and direction. Acceleration can occur if speed changes, B, if direction changes, I didn't underline that one on purpose, or C, if both speed and direction change. I didn't underline that one because in this unit, in fact, in Physics 11 and almost always in Physics 12, we're going to be looking at changing magnitude. When you let direction change, it gets really complicated. However, in Physics 12, when we look at circular motion, then direction will change. Preview of coming attractions. Now we're really going to start to flog that DFIC approach, that listing your data, finding an equation, because by, when do I see you next? Tuesday, you're going to have 4 different equations, each of which can be arranged 4 different ways for a total of 16. Don't memorize them. They're on your formula sheet. I'll teach you how to derive them up here. So, example 2, a runner running in a 100-meter dash accelerates from rest. All of us underline the word from rest. That's one of those trigger words that I will always mentally or actually underline because it means something. To a speed of 9 meters per second in 4.5 seconds, what was his average acceleration during this time interval? What's this question asking me to find? acceleration. By the way, I said average because I know runners don't accelerate constantly, but we're just going to do the math and keep it simple. So I stuck that word in there because I'm a physics nerd. Wait a minute, Mr. Dewick. You said that we're only going to be looking at a constant, we're not going to be looking at a changing acceleration. Yeah, I know, but so if I ever do have to, I'll just call it the average acceleration. That's my workaround. So let's write down A equals question mark. And now let's go look at stuff. Physics, words, and numbers. I see a 100. What's that? From rest. This is very important. What does this mean? It's a velocity. Initial velocity. How fast was this runner going initially if it starts from rest as a number? 0. I can't remember if I've told you this. I'll always do my eyes with a little curly tail so you can tell it's not a 1, because at the back corner there it's a bit tough. Okay. What's this 9? It's a velocity. Which one? How do you know it's a velocity? Okay, it's really worth memorizing units because that also makes things easier. Okay, so V final. And a 4.5, what's that? Now, by the way, one of these is just designed to throw you off. Can you see which one is actually designed to fool you? Prith. Why distance? In 4.5 seconds, have they run the full 100? You guys have watched the Olympics. In 4.5 seconds, has this person actually run the full 100? If Usain Bolt can't do it that fast, I threw that in there just to let you know, read carefully, cross that out. It's a confused, I did that, it's a distractor. It's the fancy term we use on tests. We say, oh, throw it in as a distractor. Now I'd be looking for an equation that has A, VI, VF, and T in it. There is one. I think it's right up there. It says this. Yes? You may recall in my DFIC approach, it's list your data, find a formula. We've done that. And now it's insert and calculate. So, what's V final? V initial, all over 4.5. Now, I heard someone already say 2. I did this one so that you can do it in your head on purpose, just so you can double check how you would type this on your calculator so that when you're doing ones that you can't do in your head. So get your calculator out. And by the way, if you did do this in my head, in your head, I would say, yay, because I kind of would expect you to handle it, but just to be paranoid, here's what you want to realize. A lot of the time, Courtney, we're going to have equations with big fractions. Is there a fraction here? Say yes. Is there more than one number on the top? I have to put it in brackets. In other words, if I went like this, 9 minus 0 divided by 4.5, because I heard somebody say, Dewick, I know the answer is 2. You're not getting 2 as an answer here. So we have to get good at typing things in. So it's going to be bracket 9 take away 0 close bracket. And then over is divided by. I like the fact that on my calculator it does use a slash for divided by. Matt, is there more than one number on the bottom? No. If there was, brackets. And there will be sometimes brackets. But now, is there? No. So I can just go 4.5, and this will give you the 2 that you were expecting. 2 what? It's acceleration. Meters per second squared. Turn the page. So I wrote here, the standard unit for expressing acceleration is meters per second squared. Cohen, it is my much preferred unit. An object that is accelerating at a rate of 1 meters per second squared is gaining 1 meter per second every second, if they're going in the same direction. If the object is going backwards and it's accelerating forwards, it's losing 1 meter per second every second. We're going to get away from having to figure out forwards and backwards, losing and gaining, because in the equation, we'll just decide positive and negative and let the equation take care of it. which is also a little nicer than trying to figure it out ahead of time. There is another unit that's used occasionally. Oh, here we go. Example 2. A UFO is reported as accelerating from rest. You know what? I think I would underline the word from rest because that's going to be important. To 680 kilometers per hour in a time of 2 seconds. What is its acceleration? We could, because this is seconds, convert this to meters per second. I think it's divide by 3.6. But I'm not going to because there's a couple of questions in the homework where we're going to introduce a new unit of acceleration. We're going to use kilometers per hour per second, which is still velocity over time. It's going to look like this. What do they want you to find in example 2? It's meant to be really obvious. Let's write down A equals question mark. John, what does from rest mean? What's 0? I've never said the starting point. What initial? I'm just looking for 2 letters. VI. Say it loud and proud. VI is 0. And I'll know you mean V initial. What's that 680, John? Can you give me it in 2 letters, please? Hey, there we go. What's that 2? Can you give it to me in 1 letter? And I'm going to start getting you used to thinking T time, just synonymous with each other. V final, just synonymous with each other. V initial, just it's going to be in your brain as the same thing, Jaden. I hope if I do my job right. T equals 2. I'm looking for an equation that has, well, there is. It's going to be A equals VF minus VI over 2, over T. This is a little bit weird because the time units don't match, which is why I'm not a fan of these units, but it is going to crop up in a couple of questions in the homework, so okay. Because it's going to be 680 minus 0 all over 2, 340? Yes? I did that one in my head. It's going to be 340. Now the top part is kilometers per hour. The bottom part is seconds. This UFO is gaining 340 kilometers per hour every second, which is accelerating. It's okay. So I wrote here, this UFO is increasing with 340 kilometers per hour every second. You could write it in scientific notation if you wanted to. Although kilometers per hour per second is not the officially accepted unit for acceleration, it's often used when you're describing the acceleration of a car, because what units are your speedometers in? What units are your speedometers in? Please, God, you're getting your licenses. I hope you know this. What units are your speedometers in? Kilometers per hour. You could measure time in hours. That makes for a very long experiment. But you can measure time in seconds. So, Mr. Dewitt doesn't like that unit, kilometers per hour per second, but he tolerates it because cars. Other ways to write the acceleration equation. You see this acceleration equation, we're going to write it down. A equals VF minus VI over T. How many different variables does it have in it? 4. You know how many equations it actually is? 4. 4. There's 4 different, it doesn't go by square. 4 different equations. Let's get the VF by itself. And then I wrote in brackets, in fact, this is the one that we'll use the most. See the VF, see the VF, see the VF, see it, see it, see it, see it, see it? What's this T doing? Sheldon. You're right, say it louder. Dividing. By the way, when I say that, what I'm saying is the back row didn't hear you, so you looked at me like, well, huh? It's dividing. So if I wanted to move it to this side, dividing everything by T on the right is the same as what on the left? So all of you right now, cross out this T and put it right there. I could have put it in front, but it's traditional to write AT, not T times A. Just is. And what that would give me is this. A times T equals VF minus VI. I said I want to get the VI by itself. Sorry, the VF by itself. What else is on the same side as the VF there? Alicia, what else is on the same side as the VF? VI. What's right in front of the VI? A negative or a minus? I don't, either one. So we're minusing VI. What's that the same as over here? How could I get the VF by itself? How could I move this over? Those are all the same question. What would I do? What's the opposite of minusing a VI? So you know what? That's the same equation. Or you could have written the plus after the AT, but trust me, I know how I wrote it on your formula sheet. VF equals VI plus AT. This is another equation. This is what I would use if I'm finding VF. I think that's the one that I put on the purple formula sheet, is it not? Should be about 3 lines down. Or yeah, we're going to be flogging that to death. In fact, my physics 12s are still flogging that one to death. There's a lot of profoundness in that equation. Why do I like that one? Because Courtney, no fraction. Kids don't like fractions, I've learned. Okay? Oh, we could also get the VI by itself. How would I get the VI by itself? What else is on the same side as the VI and AT? What's the AT doing to the VI? Plussing, so how would I move the AT over? You want another equation? Another equation would be the VF would drop down like a domino. It'd be a minus AT. Look up, Alex, though, before you write. Don't write this down. Don't write this down. I could do this, except we like seeing the thing by itself on the left-hand side. So I'll put it there. VI equals VF minus AT. What if I wanted to get the T by itself? Okay. I'm going to write down VF equals VI plus AT again. I want to get the T by itself. See it, see it, see it, see it, see it, see it, see it? What's right in front of the T? What letter? Courtney. A. What's the A doing to the T? Adding, subtracting, multiplying, or dividing? So how will I move the A over? What's the opposite of timesing by A? Okay, but you know what? Turns out you do that last. What's the VI doing? Adding, subtracting, multiplying, or dividing? Adding. How will I move it over? To get the T by itself, the VF will drop down like a domino. I'll minus the VI over. Don't write this next bit down, just watch. That would have the AT drop down. Courtney, how did you say I'm going to move the A over? Don't write this down. Courtney, I like to have the thing by itself on the left-hand side. So instead of having equal T, I'm going to go T equals. Here's our, you can write that down. There's our equation. Jaden, you're going to, by Christmas, be able to do all that in your head, showing no steps. And if you can, I'll say great, because it's a much better way. You can memorize this equation and this equation and this equation. Don't! Please don't. Or you can derive them all from this, even better, in your head. Little note, by the way. All of us have a built-in accelerometer. All of us can feel acceleration. Only one problem, Cohen. All of your built-in accelerometers work backwards. Really? Yeah. I'll prove it to you. When a car is stopped at a red light and the driver floors it, first of all, which way are you clearly accelerating when the driver floors it? Forwards or backwards? Forwards. Which way do you feel like you're getting pressed? Backwards. Your bodies have built-in accelerometers, Trevor, but they just work backwards. I haven't convinced you yet. Okay, Trevor, you're in a car and the car hits the brakes and stops quickly. When you hit the brakes, slowing down, which way are you accelerating? Forwards or backwards? Backwards, but which way do you feel like your body's going to get thrown? Forwards. I'm telling you, your body has a built-in accelerometer. It's just back. So which way do you feel like you're getting pressed? Forwards, but You're accelerating backwards. That's slowing down. I still haven't convinced Trevor because he got here late. Trevor, have you been on the elevator before at Playland? Anybody who's been on the elevator? Okay, so imagine you're on the elevator. When it's shooting you upwards, clearly, which way are you accelerating? Upwards. Which way does it feel like your stomach is going, though? Downwards, right? You feel like you're getting pressed downwards, but you are accelerating upwards. Did your Science 10 teachers teach you this last year? Because this, to me, is fundamental. Whenever they ask me a direction question in Science 10, I just imagine I'm on the ride, and I say, which way do I feel like I'm getting thrown? It's the other way. Always. Oh, because also, when it's shooting you downwards, which way are you clearly being accelerated? Downwards. Which way do you feel like you're about to fly off, though? Upwards, right? So you feel like you're being pressed up, even though you're accelerating downwards. When you typo. When you ride, I'll fix that. When you ride, what's the Music Express ride at Playland? Does anybody remember which one that is? Which one is that? What path does it trace out? What shape is that ride? Okay, big circle. It's the one, who wants to go faster? I don't want to go fast. We're going to go faster. Okay, you go really, 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 really fast. You've been on the Music Express ride? Okay, John's smiling. Which way do you feel like you're getting pushed on the Music Express ride? Outwards? Which way are you accelerating then? Inwards, yep. Physics 12 will look at circular acceleration, and the biggest thing I have to beat out of kids' heads, because they've done Playland, they think when you're moving in a circle, you're accelerating outwards because that's which way they're getting pushed. No, you're accelerating inwards. You're accelerating inwards. If you're ever moving in a circle, I guarantee you're accelerating towards the center of the circle. Really? Yeah. Couple more, we're done. 1, 2, 3, 4. Oh, this is great. You even have time to work on the homework. Read example 4 to yourself. I'll read it out here. A car starts from rest. You know what, Haley? I would probably underline the word from rest. That's important. And accelerates at 4.5 meters per second squared for 3.6 seconds. How fast is it now traveling? What's this question asking me to find? Let's write down VF equals question mark. John, from rest, what's that telling me? 2 letters, please. What is VI, John, my friend? As a number, how big? Thank you. What's that 4.5? I think I disagree with John. John, can you read me the whole thing and the units, please? How do you know it's acceleration and not VF? You know, if you had a good physics teacher, he would have said, it's really worth memorizing what units go with what because it really cuts down on your thinking. Yeah, yes, yes. I don't know why I'm picking on you today, but I am. What's that 3.6? Jess, time? I'm looking for an equation that has VF, VI, A, and T, and I'd like it to have the VF by itself. I think this one. By the way, technically, Trevor, I could go vector, 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 but since I haven't given any indication of direction in the question, we'll do our usual forward will be positive, backwards will be negative if we get that. So I'm kind of doing it with a scalar method, and if I get an answer that requires me to interpret the direction, backwards is going to be my fallback. 0 plus 4.5. Why did I change colors? I don't know. Let's go keep going in black, Mr. Dewick. 0 plus 4.5 times 3.6. Can I do that in my head? Maybe. 4.5 times 3 is going to be 13.5. 4.5 times 0.6 is going to be 1.8. 13.5 and 1.8, 15.3. Double check me. No, I'm way off. Hang on, I'm way off. 16.2. God, I forgot to carry a 1. 16.2. what? We always check units at the very end. How do you know it's meters per second? What were we trying to find? Oh, you mean if I memorize the units, I can just right away almost like barf the units right onto the page from my pencil? Oh, great. I like that. And I tend to put a box around my final answer. By the way, technically, how many sig figs? 2. How many sig figs? 2. Technically, should be 16. I told you I'm not going to worry about that for the rest of the year. Example 5, a car is traveling at 110 kilometers per hour when it hits the brakes and accelerates with a magnitude of 8 meters per second squared. How many seconds will elapse before it comes to a stop? What's this question asking me to find? T? Okay. Let's do our usual read along. I see 110. What's that? VI. Except what don't I like about it? Now, we did do one where we did kilometers per hour per second. Did they give me the acceleration in kilometers per hour per second? And what do they want the time in? Time in second. You know what? Let's do a conversion. So I'm going to write VI equals 110, and I'll stick the units in. It's times or divide? Or it's on your formula sheet, right? I was just on a freeway going 100 kilometers per hour and multiplied, and it didn't work, and I said divide. Divide by 3.6. I get 30.55. I'm going to write 30.6, but I'm going to store this answer on my calculator because I have a good calculator because I had a physics teacher who went on a bit of a rant. Okay. What's that 8? This is not enough. Right now, I have 1, 2 things. I think I need 3 things to find the 4th. What am I missing? Oh, okay. What is VF? What? Nice and loud, loud and proud. What? Where'd you get that from? Okay, so I've already told you I often underline the word from rest. You want to know another word I often underline because it's a physicsy word? Stop. And the nice thing about both those, Haley, from rest and stop, there's zeros. I'm good at doing math with a 0. I'm looking for an equation that has time, VI, A, and VF in it, and it'd be nice if I had the T by itself. I think I have that. What's the equation? T equals... Oh, wait a minute. Look. I'm going to get the T by itself from this equation right here. Wouldn't I drop the VF down because it's not on the same side as the T? I would minus the VI over. And then, oh, there's an A. How would I move that over? I can derive, Cohen, that equation with some grade 8 equation solving. It's going to be 0 take away 110. Oh, no. 30. And again, I'm going to write 30.6 here, Jess. I'm going to use my answer button on my calculator. Divided by 8. Now, when you do this, you're going to get a weird answer because we have made a mistake. So first of all, try this. What do you notice about your answer? Try typing this in. What do you notice about your answer that's a bit weird? What? A negative. What are we finding? Time? Okay, we can't have a negative time. What's the very subtle error that we've made? Why should the acceleration be negative? We're slowing down. We're slowing down. So here's a third thing you can't. Now, I missed that on purpose to let you know, Cohen, if you do miss that, hopefully when you're finding time and you get a negative answer, you'll freak out enough to know something's wonky because Duick has said we're not allowed to go back in time, no negative time. Right? You guys, when you typed it in, you said there's more than one number on the top. You went 0 minus answer button divided by 8, and you got that, yes? Something's wrong. Can't have a negative time. So go back, put a negative right there, because we are slowing down. If you want to, you can even, for your notes, draw a little arrow saying slowing down, so that when you're studying later, you know what the heck we did. So if I fix that, there's my 30.5. If I go 0 minus answer button divided by negative 8. Now here's the nice thing. I get the same magnitude. I get the 3.5. So, but now the sign is fixed. So there's your ding, 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 ding. Pay attention. Something's gone wonky. Little alarm bell. I'm going to go 3.82. 3.82. What? Seconds. One more. A dragster. Hopefully you know what a dragster is. The big car with the little tiny wheels. The big goes really, really fast. That thing. Starts out from rest and reaches a speed of 30. Oh, what does this question want me to find? In meters per second squared, so don't go with the kilometers per hour per second stupid unit that I hate, that I only tolerate because of, you know, cars. So A equals question mark. I would probably underline the word from rest, because I think that tells me which V. What's that 37.8? What final? V final. Now, I hope it seems like I'm going a little slow. We're going to kick it up a notch and a half next unit when I introduce all of the kinematics equations, and we really have lots more to work with. I'm looking for an equation that's got A, VI, VF, and T, and it'd be nice if the A was by itself. Now, I notice at the top of the page, that's the one that I put on your formula sheet, I think. How would I get the A by itself? Now, I know you have it if you turn back a page, but you know what? I'm too lazy to do that. See the A, Alicia? See it? See the A, Alicia? Yeah. Okay. I'm going to eventually, I think, divide by T later. I need to move the VI over. How will I move the VI over? Okay, so Jaden, if I hear you, the VF just drops down like a domino. You're saying I'm going to subtract the VI, and then I'll divide by the T, and if it's okay with you, I'm going to put the A on the left, because that's where I like to see it. Okay, now it's plug and chug. VF, 37.8. By the way, Connor, are we speeding up or slowing down? Should we get a positive or a negative answer? Oh, so I can even make the prediction ahead of time if I'm really paying attention. And this, Lydia, you have me for Science 10. See, this is how they should have done direction in Science 10. You're speeding up. Just call it positive, for Pete's sakes. Don't go all this north, east. Oh, geez, Louise. Don't get me started. Yeah? Oh, 18. That is about right, by the way. I looked it up. Dragsters accelerate at around 18 meters per second squared. Mr. Dueck. What, Prith? How many G's is that? We'll talk about that in the next lesson. I'll tell you what we mean by how many G-forces. G-forces is the wrong term. It should be acceleration. But we'll actually learn how to calculate G's. And we'll talk about what would kill people and what would help people survive and all that stuff. So that's coming down the pipe as well. What's your homework today? I wrote do these on a separate piece of paper because I just don't think there's room to write everything here. Or do you guys have a blank page on the back of your homework? If you want to do it on that blank half page, whatever. But I would recommend doing these on a separate piece of paper. If you do, how about as a title, Lesson 1 homework exercises would really, really help. I think number 1 is good. 2 is good. So number 1, I'm asking you to find an acceleration in kilometers per hour per second, which I hate. And then give your, anyways. 3 is good. Oh, let's do Usain Bolt. 5 is good. 6 is good. You've assigned everything so far? Yeah, I might. Oh, it's a roller coaster. I have to do a roller coaster. Tesla. I took a Tesla for a test drive this summer. It was too cool. Oh, yeah. It was my nerd highlight. Anybody been on California Screaming at Disneyland? These are the numbers. I Googled them. So if you wanted to find out what you're accelerating at on that. I'm going to skip 10. 11 is good. 12 is good. 13 and 14. So I think I just skipped 10. Yeah? I could have said everything skip 10. You got 20 minutes. Lots of time. I think you probably, even if you hustle, get it done in class. Also, hand in any missing homework from the last unit, please.